One thing we've learned from 20 years of RoboSub is that hardware and software technology improves every year, and the students are dedicated to keeping up with it.
Recent years have seen dramatic cost reductions in basic underwater technology, like thrusters and off-the-shelf hull enclosures. While some teams still go the homebrew route, many have embraced the freedom to focus on other custom hardware, or to expand their perception systems into the realm of acoustics as well as vision.
The technology itself is advancing year over year, and our goal is to make use of the newest technology. The computer vision is developing, and I've heard people are using machine learning for the controlling system. That's amazing. That's definitely going to be something we can look into in the next few years.
We've seen a lot of platforms. They have more beautiful and compact housings. Maybe in a couple of years we'll try to buy the whole housing and try to create only our electronics.
Hydrophones, it seemed to us as a new team, was a very crucial part of coming here and have a functional system. The first hurdle that we had was finding the proper data gather unit. We end up just getting a unit to do the work for us.
At RoboSub, good ideas have a tendency to spread. Innovative configurations of things like pressure holes quickly become trends, even as teams continue to push the design envelope.
So this year's design is using a center bulkhead with 2 holes on each side, and the idea behind that is really for stability. So we keep the computer on one side and we put all our IMUs and then the PCBs on the other. At first we actually had them together, and then we were seeing a lot of interference. So moving them to the other side was huge in filtering out that magnetic interference.
We try to put all our custom electronics in one side and all our store-bought electronics on the other side, so we can try to separate them out. So if something breaks on ours, which does happen unfortunately, everyone knows exactly what's going on that side.
The general tech trend of more powerful computers in smaller packages continues, but the recent arrival on the scene of feasible machine learning vision has led some teams to wrestle with the space, power, and heat requirements of squeezing high-performance computing hardware into their robots.
This year we have a very large submarine. A lot of that is because we chose to use a laptop with an NVIDIA GTX 1060 in it instead of the embedded systems that we have been using in the years past.
We designed the general structure with the idea of putting a big computer in, but we really didn't do our due diligence to make sure we were leaving enough space for all the wiring and water cooling tubing. So if there was one thing we would have changed, it'd just be make everything bigger, because a bit too much space is better than not enough space.
The use of simulation to speed up the design and testing loop continues to accelerate. Teams are increasingly making use of complex simulation software toolkits.
Hardware hacks are also used for simulation and testing, especially amongst teams that can have some difficulty ensuring access to in-water testing throughout the year.
Simulation is great for maximizing your time efficiency. Our simulator is designed to be hardware in the loop for everything. As soon as you plug one piece of hardware in, it immediately recognizes that, switches to hardware mode for that specific sensor, and you can test your motors, you can test your sensors, you can test your actuators that way.
Relatively new to the electronic design community is Altium Circuit Maker, which gave me the ability to model components in 3D that I could then insert into our robot's 3D model.
Because our submarine is in development, always constantly changing mass, changing geometry, there are adjustable thrust motors. The change in orientation essentially allows us to align the thrust along with the center of mass. So that minimizes the amount of oscillations we get because of discrepancies between the thrust and center of mass. And also it saves time with PID tuning.
One thing is certain, trends in hardware and software will continue to be on display at RoboSub.
And these brilliant students will always give us a glimpse at the future of the technology applied to maritime autonomy, as they have for the past 20 years. We'll always make sure that their vision gets the recognition it deserves here at robonation.org.